Hey, what's up? This is Madan sir here, and I'm going to do the very next topic from alcohol, phenol, and ether. And this is again very important. Why? Because this relates to all the conversion, based on the phenol. And what you have here is it's called chemical properties of the phenol. So I've written the topic here, phenol chemical properties, and I tell you what, that phenol, since it has a hydroxy group, and therefore it exhibits plus R effect. So benzene with plus R effect, has a unique property is that it gets activated towards electrophilic substitution reaction. And because phenol is electrophilic, is getting activated towards electrophilic substitution reaction, so it easily undergo substitution of, hydrogen by any other, electrophile. So let's see how this is it, and I'll take the example there. So the first thing I want to tell you that benzene exhibit plus R effect and therefore benzene gets activated towards electrophilic substitution reaction, by involving replacement of hydrogen from ortho and para position. Right? So this is what the writing part is. Let me explain you here again. Since phenol exhibit movement of electron towards benzene, right? So negative charge either develops on this side or on this side or on this side. So probably you do know that these are ortho position and that one is a para position. When phenol undergo chemical reaction, what it can undergo, it can add electrophile by removing the hydrogen itself, right? And this is what called activation of benzene. So let me write this. Plus R activate benzene ring and makes it electron rich, and therefore so it's easy for phenol to react with electrophile, and not with nucleophile. Right? So this is very important part. Now let's take example. What kind of reaction does benzene undergo due to presence of phenol here? Okay, so now let's see what kind of reaction benzene can undergo. So the first reaction I'm telling you is that it exhibits electrophilic substitution reaction, right? So it exhibits electrophilic substitution reaction where the first reaction is called nitration of phenol. It's called nitration right? In the nitration, what you have to do, you have to react the benzene with hydroxy group, so therefore it becomes phenol. You have to react the phenol with HNO3. So probably I have told you so many times earlier that HNO3 exhibit two ions, OH negative and NO2 positive. So this is the electrophile here and this is the nucleophile here. So what will happen, hydrogen from this place, is also an electrophile, and hydrogen from this place is also an electrophile. So nitrogen will displace both of these, hydrogen, and therefore the two products coming out to be will be orthonitrophenol and paranitrophenol. So the first product is orthonitrophenol. What this is called? This is called orthonitrophenol. And another one, like I said earlier, that this is going to be paranitrophenol, and the para position is this one, right? So again, one very important thing, this is going to be a minor product, and this is going to be a major product. Why this is major? Because it is symmetrical, and this is unsymmetrical. Now the question is, these two products, how they are going to get separated. So the question is, let me tell you a bit here, that the first reaction that the phenol can undergo is nitration. In the nitration, phenol react with HNO3, and since HNO3 contain two ions, NO2 and OH negative, where the NO2 is the electrophile part, so electrophile will displace two hydrogen from ortho and para position, and therefore you get two products. Now the question is how these two products are separated. So to separate orthonitrophenol and paranitrophenol, steam distillation is carried out. Distillation is carried out. Where orthonitrophenol having lower boiling point, separate first and then paranitrophenol. Right? So this is how they are separated. Now the question is why paranitrophenol has a higher boiling point and orthonitrophenol has a lower boiling point, right? So that's what I'm going to say here. Orthonitrophenol is, this is the structure I just made you a bit while. So this is the orthonitrophenol, right? Now if you probably know, in case you don't, then this will help you. Actually, there is a hydrogen bond here. There is a hydrogen bond between the, in the nitrophenol. So this is called, intramolecular. This is called intramolecular hydrogen bond, and it is weaker. You have to understand that this is a weak bond as compared to other one. What other one is? Let's see here. So I'm taking the next one, which is paranitrophenol. So this is your paranitrophenol, right? And there is your nitro group. Now what happened? hydrogen bond is formed, but this time the hydrogen bond is formed between two molecule of, para-nitrophenol, because these two are very far away from each other, so it cannot form a hydrogen bond of intramolecular type. So what happened, there is the hydrogen bond. So this is called intermolecular hydrogen bond. This is called intermolecular, right? Intermolecular hydrogen bond, and it is stronger. It is stronger, right? So because intermolecular hydrogen bond is stronger and it is present between the two molecule of para-nitrophenol, so it has a higher boiling point. So if you perform distillation, this one will evaporate first and get separated. Later on this will also be separated. So this is really very important, how the separation of the ortho and para-nitrophenol is carried out. I have to move on to the next topic, right? So what next topic is, the next topic is going to be if phenol react with concentrated HNO3, then what happened? Not only the ortho and para, but also the meta positions hydrogen are also substituted by the nitro group. So this is what happened. You have this hydroxy group, but you have nitro group here. The second one is already there, right? And what happened actually, that even the meta position, nitro is also occupied. This is, this is what the condition is. Sorry, this is what the condition is, where all the three positions are, occupied by the nitro group. So, like I might have made mistake. When you use concentrated nitric acid, all the three positions are occupied at the same time. You don't get two results, ortho and para. You get, a compound where all the three positions, two ortho and one para, are occupied by the nitrite group. So this is what this is called. This is called, 2,4,6. This is called 2,4,6 trinitrophenol. Trinitrophenol. But this is only possible when you use concentrated HNO3. So this is another reaction important related to nitration here. Okay, what next we have? Bromination. So in the bromination, what happened? A phenol molecule react with bromine, but bromine is dissolved in carbon disulfide, CH2. So what that means, that the bromine is diluted. Why? Because bromine is not absolute. So what happens? You get two products again, one on the ortho position and other on the para position. So you get, first product, this one, this is called ortho bromophenol, but another one, probably you do know, is going to be this one. And what this is called? This is called para-bromophenol. So the reaction takes place in the same manner. Now the question is, what will happen if we use only bromine water? So if you react, phenol with bromine water, concentrated bromine water. So what happened? All the three positions, just like this one, will be occupied by the bromine. So you get one bromine right here, other bromine right here, and the third one will be there, right? So what this is called? This is called 2, 4 and 6 tribromophenol. right? So if you increase the concentration of nitrite ion and any electrophile, the substitution takes place at all the positions possible. So there are 3 positions, 2 of the ortho and 1 of the para. So that's what happened, when you use dilute and when you use concentrated.